So, influence of process parameters that we were discussing before, and we will continue with that till all the 4 parameters that we thought about: temperature, time, twist and tension. So, what we had basically learnt is that the process parameter that influence property of textured yarn are 4: temperature, time, twist and tension. Effect of temperature on crystallinity, crimpidity, tenacity, dye uptake we have seen. Role of heating and cooling time and the effect of time on crimpidity, tenacity, and how does one calculate a nominal twist, just as a thumb rule before you start optimizing as to how much twist is required. So, we work about twist, continuing with that. We will see what are the interesting effects that the twist or textured yarn will have, and influence of the tension as well. We still are working on fully drawn thermoplastic filament yarn. So, that is our boundary condition. It is a single heater texturing machine and twist texturing. So, we had learned about how much approximate twist should be given, which is relatively much higher than a normal twist compared to, let us say, a spun yarn twist. So, the yarn can obviously, when you bring together 2 ends, it will snarl. So, the effect of twist on the crimpidity, that is, when you change the value of twist, what happens? Any guesses that you would like to take here? What would happen if level of the twist is changed? Yeah?
Up to certain extent increase and then decrease.
All right. So, this will increase and then decrease. Now, why does it increase and why does it decrease? That is what will be an interesting. So, the increase is because the number of helices are increasing, and therefore, the initial increase is there. Why would it decrease? Right? So, important thing that has just been brought out is that there is a question which gets associated with tension. If the take up and the feed roller speeds are same, and then you only increase the twist. So, when increase the twist, tension increases. Means tension increases. Now, tension has a reverse effect compared to anything else, because this whole process of setting is a relaxation process, that the molecules are relaxing either to crystallize or to disorient. So, in all these cases relaxation takes place. In case we have a situation where the tension increases, because as you increase the twist, of course, the number of helices per unit length increase, but the tension in the yarn also increases, which means relaxation is going to be hampered, and therefore, setting is going to be hampered, and therefore, you would also have a situation where we would not be having proper setting, and so crimpidity then can increase and can go down. So, what should be the effect of twist on tensile properties? Let us look at first the tenacity. What do we expect would happen to the tenacity? Will the tenacity increase Yes? First increase, then decrease. That means whatever we are expecting in the case of crimp rigidity, same kind of a curve you are expecting. Before we say it's right or wrong, would you like to just give an explanation why should it increase? You don't agree? It should not increase. Why should not increase?
Orientation will change. I mean, disorientation will take place.
Right? Anyone else?
We are applying twist, so there will be high tension that will hamper the disorientation process.
And therefore?
Therefore, first it should be increased.
So one of the argument is because there is tension and therefore it would help to increase orientation and therefore tenacity may increase. All right? But it's a bad argument because the yarn is twisted. When you say you are increasing tension, you are increasing the tension in a twisted yarn. Which will mean is if the fiber is lying like this, the tension is in this direction and therefore the orientation in the direction of the fiber axis is not going to be high. So, we started from the beginning itself, texturing is a disorientating process. A large number of filaments are lying on a twisted yarn obliquely. They are not obviously parallel to the yarn axis is not parallel to the fiber axis. So, whatever you do, increase the number of helices, it is only going to be from the orientation point of view, it will be not good. All right. And therefore, a good crimp rigidity actually means more better setting and that also somehow represents that the fiber orientation is not the same, it is actually going toward the negative side from the fiber point of view. Because when will you measure, how will you measure the tenacity? Tenacity will be of a textured yarn when there is no twist. When you will be measuring tenacity of a textured yarn, there will be a parallel bundle. While the setting was being done when they were not a parallel bundle. So, this situation is very different from fiber drawing. When you draw the fiber, then the fiber filaments are parallel to each other and then you are pulling. Effect is obviously different. In this case, even if you pull, you are only going to do a bad job as far as the orientation is concerned. And if tenacity is related to orientation, then we can't expect anything better. Like we said, whatever you do, you increase the temperature, the tenacity of the textured yarn will always be lower than the parent yarn. So, you will always get tenacity lower, whatever you do. So, it will be reduced based on the environment, the curve may be different, but you can always say tenacity is likely to go down only. All right. Once somebody had asked a question, when we are producing a modified stretch yarn by reducing the stretch. So, we first make a stretch yarn and then reheat under a different condition and we hope that stretch is going to be reduced. The question was why can't we give less number of twists and get the same effect, right. So, why do we have to do two steps? First do setting or texturing at a high twist level, then after texturing you do a modified stretch in a secondary heater. So, why can't we just reduce the stretch by reducing the twist, all right. So, this was a common type of a solution to a problem. It was not done because it is still not done, because you actually do not produce a good yarn. So, what a statement was made that when you have more amount of twist in a false twist machine for that matter, then during untwisting there is more of unbending which takes place, because the helices are more flat, and so when the reverse twisting takes place, there is unbending of the coils takes place, unbending. Okay. But if the twist level is low, let us say this is the twist level, then when you do the so called untwisting, reverse twisting can take place. That means, all the filaments actually get twisted in the other direction rather than each filament getting unbent. So, the result that happens is that actually you have some real twist in the yarn. So, although twister is the same thing, S is becoming Z, but instead of each filament being opened and so that they remain individual, the whole yarn as a bundle can get reverse twisted. So, in situations where less twist is given, people saw that there is less unbending and more reverse twisting, while our aim was whatever has happened, I want to unbend the yarn, so that they become again a twist free bundle of twist lively filaments. So, here the yarn becomes lively and not the filaments remaining the one which want to jump back to their own position, and so that is not a good idea, and therefore, we are still continuing with two-step process. Are you getting the point? So, when you have more twist, more unbending takes place. When you have less twist, then the chances of reverse twisting increase. That means, some real twist gets inserted in the yarn. That means, the bundle is no more a twist free bundle. So, that is one interesting aspect. So, we come to the last parameter which can be controlled, and how do we control this? The speed of the feed roller and the take up roller can be changed, and then you can change the tension in the yarn, right, which obviously has been twisted. We assume that the twist is same, the temperature optimized is same, the time, that is the speed is also same, only the tension can be changed. So, the final output is keeping the same, some tension can be changed. So, there is a control. So, you have a control, whatever tension you want, and something you have already talked about tension in the section that we were talking about, the twist. So, once we have understood the effect of tension during texturing, what should we do? We have a control on the feed roller and a take up roller. What do we do? Underfeed, overfeed, or run at parity? That means, the speeds are same. Overfeed. Why do we overfeed? Why do we overfeed then? Soft package. That means, you definitely would not first do underfeed, because you are only going to be increasing tension, which is not good for setting purpose. In the parity situation also, there can be tension. Normally, if you run a yarn, the speed of the two rollers is same. What do you expect to be tension? You are feeding the same amount of yarn and collecting the same amount of yarn. So, between the thing, how much tension could be there?
Which we give in the starting.
All right. So, whatever tension that you have kept it in the beginning, that is one which can continue, if that is what we are looking at. But in this case, it is a thermoplastic yarn and it is being heated. and heating means you are allowing molecular relaxation. So, stress in the yarn generates because the molecules want to relax and you are not allowing it to relax, and so stress generates. So, there are two things can happen, because we know thermoplastic yarns shrink on heating, and if you do not allow shrinkage, then the stress will build up because of thermal relaxation, and that means if you do at parity, you will have large amount of tension, which anyway is not good. So, we reject this, we reject this. So, overfeed is the only thing left. So, we control the tension by controlling overfeed. So, about 10 to 15% overfeed can be given. Does it mean that the yarn will be totally relaxed? If yarn is totally relaxed, you can think you are twisting the yarn at a high speed, it will keep jumping off from one place to another. It is supposed to traverse its path on the surface of a heater. If there is no tension, it will go away from the surface of the heater, particularly when you are rotating at a faster speed. Therefore, to run the yarn while you are twisting, minimum tension is required, so that it remains always in contact with the heater. So, what it also implies is that even at 10 to 15% overfeed, you may still be having the yarn under tension. You would like to run it at a 0 tension, but you will not be able to run at a 0 tension, because then the yarn will jump off, because it is not something which is just passing over a heater, it is being twisted at a high speed when it is passing over a twister. All right. And therefore, there will be tension. So, certain minimum amount of tension is required to operate the machine itself, but you would like to keep it as low as possible, so that the setting is better. Higher tension is not good. It is not that yarn is going to break, but setting is going to be affected, right. So, anyway, this was just a diagram of the machine, line diagram, which obviously you can't see it now, that I have already written something over it. So, effect of tension on crimpidity will be, the crimpidity will reduce if you increase the tension, and this is what we discussed before, and that is why you would like certain amount of overfeed to be given. Okay. Within that also, you can change the overfeed and get the value of crimpidity, right. Keep changing the overfeed, and therefore, you will keep changing tension, and you can see effect of this on the crimpidity. So, it is like a good project which you can do. So, we summarize, and what we are doing is that we have seen that there are various material and process parameters that influence the texturing, and we have also seen some of their effects on the property of textured yarns, whether it is the change of material and the specific heat and what not, or the process parameters like temperature, time, twist and tension, and any other thing related like dyeing, effect on dyeing and structure relationship also we try to understand. So, we will in the next class change the topic. As of now, we had the boundary condition where we were using only fully drawn yarns. Now, we will go to another type of a texturing which is called draw texturing, where it may not be a fully drawn yarn that you want to handle, you will like to handle a different type of yarn which can be drawn on the texturing machine itself. So, here we stop for today.